Hello everybody. Today we'll start our second lesson in geometry, position of a point and straight line with respect to a circle. First, we'll start with position of a point with respect to a given circle. If M is a circle with radius length R and A is a point in its plane, then A like this, then A is outside the circle M if MA greater than R. We find that A outside the circle, so MA greater than R. Number two, if we have also circle M like this, and we have A point on the circle M, like this, then it means MA is equal radius. So A is on the circle M if MA equals radius length. Number three, if we have circle like this, circle M, and we have point A inside the circle M, it means MA less than the radius R. So we have three cases. Number one, A is outside the circle, then MA greater than R. Number two, A is on the circle, so MA equals R. Number three, A inside the circle M, so MA less than radius. Let us see exercise about this. If M is a circle with radius length 4 and A is a point in the plane, complete. Number one, if MA equals 4 centimeter, we have here the radius is equal 4 and also MA is equal 4. It means A is space circle M. Yes, on the circle M, because MA, length of MA is equal to radius length. If MA equals 2 root 3 centimeter, then A is a space. 2 root 3, it means value less than 4 centimeter. If you will find it by using your calculator, you will find that 2 root 3 smaller than 4. Then A is inside the circle M, because MA less than radius. Number 3, if MA equals 3 root 2, 3 root 2 greater than 4, it means A is outside the circle, because MA greater than radius. If MA equals 0, then A is on the center of the circle. 0, it means A on the center of the circle. Let us see the second part of our lesson, position of a straight line with respect to a circle. I have also three cases. If MA greater than R, it means A outside the circle, then the straight line which is passing through this point A, which you call L, is outside the circle. Number two, if MA equals R, it means A lies on the circle, then the straight line L which is passing through the point L, the point A, touches this circle. So it's called tangent to the circle. Case number three, if MA less than R, it means A inside the circle, so the straight line which passes through this point A cuts the circle, so it's called the secant to the circle M. Now I have straight line outside, number two tangent, number three secant. Let us see what is this, what is the meaning of L intersection circle M and L intersection the surface of circle M. Before I start, what is the difference between circle and surface of circle? Circle like this, it's called the circle M. But surface of a circle M, it means this part and all the circle, all parts inside this circle. That is the difference between the meaning of circle and surface of circle. Let us see what is the intersection between L and L intersection circle M and L intersection surface of circle M. Here, L intersection circle M is equal to phi. And the L intersection surface of circle M also equals phi, because I have here no intersection between this straight line and circle. Number two, in the case number two, L intersection circle M. We find the intersection between this straight line L and the circle, this point. So I can write set of A, means this point. And also L intersection surface of circle M is equal set of A, this point also. Number 3, here I wanted to find L intersection circle M and L intersection surface of circle M. L intersection circle M at these 2 points, X only and Y only. So I can write it as a set like this, set of X and Y. But L intersection the surface of circle M, surface of the circle M, it means this part, the line segment XY. So the intersection here between this straight line and surface of circle is XY, line segment. Here I have 2 important facts. Let us see. Number 1, if the tangent to a circle is perpendicular to the radius drawn from the point of tangency. What is the meaning of this? If I have a tangent like this straight line L, this is a tangent, and this point is called point of tangency, and I draw the line from the center to the point of tangency, it must be perpendicular. It means the measure of this angle must be equal 90. So if I draw, for example, tangent like this, if I draw like this, and I draw line from this point, from the center to this point of tangency, so it must be perpendicular. Number 2, the straight line which is perpendicular to the diameter of a circle at one of its ends is a tangent to a circle. It means if I find diameter of a circle and this diameter is perpendicular to the straight line, it means they make angle with this straight line. So this straight line must be a tangent to a circle. Let us see some exercise about this. Here we have BC is a tangent. I have BC is a tangent, like this. And the measure of angle C is 45. D is the midpoint of AH. I wanted to prove that DA is equal to DM. Before I start, we know that if we have a tangent, so this diameter must be perpendicular to this tangent. It means measure of this angle must be equal 90 degrees. So I can write like this. BC is a tangent. It means AB is perpendicular to BC. So measure of angle ABC is equal 90. Here from the figure, I have triangle ABC. Measure of angle B is equal 90 and the measure of angle C equals 45. So I can find the measure of angle A. Yes, we know that sum of measures of interior angles of triangle equals 180. So measure of angle A is equal 180 minus 90 plus 45. It will be 45 degrees. Then measure of angle A 45. After that, we know that D is the midpoint of AH. And we said before, if I have midpoint, it means MD is perpendicular. It means the measure of angle MDA is equal 90 degrees. Or ADM equals 90. I wanted to prove that, remember that I want to prove that DA is equal to DM. It means DA equal DM. So I need to find the measure of this angle. If I talk about this triangle ADM, we know that sum of measures is equal 180. So to find the measure of DMA, 180 minus 90 plus 45, it will be 45. It means, so measure of angle DMA is equal 45. So I have measure of A is equal to measure of DMA. Each of them equals 45. Then DA is equal to MD. Let us go to another exercise. Here we have AB is a diameter. And also AC is a tangent to the circle at A. Measure of angle DMP equals 100. I wanted to find the measure of angle ACB and the measure of angle CDM. We know that AB is a diameter and AC is a tangent. It means the measure of this angle is equal to 90 degrees. So I can write like this. Since AC is a tangent and AB is a diameter, then AB is perpendicular to AC, then measure of angle BAC or measure of angle A equals 90. I want to, and I have also measure of angle DMP equals 100. I wanted to find the measure of angle SACB. It means the measure of this angle. I know that I can't find the measure of angle directly. I need to help. It means I need to find the measure of angle P. How can I find the measure of angle P? We know that if we have a circle and with center M like this, and the MD, MP are 2 radii, it means the measure of this angle is equal to measure of this angle. So I can find the measure of angle P like this. MD equals MP, 2 radii, and the measure of angle DMP equals 100. So measure of P equal measure of D, each measure of angle MDP. Each of them 180 minus 100 divided by 2, it will be 40 degrees. So I can write here 40, and here also I can write 40. Now if I have measure of this angle 40, so I can find the measure of angle C by using triangle CAB. It means 180 minus 90 plus 40, it will be 50 degrees. So measure of this angle is equal 50 degrees. Now I wanted to find the measure of angle CDM. CDM, it means this angle. I can find the measure of angle CDM, but we know that CDM is an exterior angle of triangle DMP. It means the measure of CDM is equal sum of measures of 2 interior angles, this and this, except the adjacent or non-adjacent angle. It means the measure of angle CDM is equal 100 plus 40, it will be 140 degrees. Let us see another exercise. Here I have DCEZ. DC touches a circle. DC touches a circle at M. DC touches a circle M at C. And here I have AB is parallel to MD. AB parallel to MD. Measure of angle BAC equals 80. And the measure of angle MDC, this angle is equal to 8. Find the measure of angle ECM. ECM, this angle. Required angle is here. I want to know measure of this angle, ECM. From the figure here, I have 2 parallel lines. And I have a tangent. I have 2 parallel lines and I have a tangent. So, if I have a tangent like this, DC is a tangent, it means the measure of angle MCD is equal 90. So, I need to find the MCE, it means I need to know measure of this angle only. I have here PA is parallel to MD. So I must use this parallel. But before I use this parallel, I can find the measure of angle M here. Yes, sum of measures of interior angles of triangle 180. So measure of this angle is equal 180 minus 90 plus 20, it will be 70 degrees. Here I have PA is parallel to MD. It means measure of angle MEC is equal measure of angle A equal 80 degrees corresponding angle. Now I have here 80 and here 70, so I can find the measure of angle ECM 180 minus 80 plus 70. It will be 180 minus 150, it will be 30 degrees. Thank you for watching. Meet you another time.